All right. I'm sorry I can't be there today, but you're going to be fine because we're going to do the exact same thing that we would do if I was there. This is what we're going to do. We are going to practice completing the square. We learned how to complete the square all last class. A lot of you were not really mentally into it, so you're going to have to be quickly. You will then be taking your quiz. You will be doing it independently. However, I will allow you to use your notes. Though I don't want you to, I'll allow it. Okay? Then we are going to do the last lesson of the unit. There's been 6 total lessons. Okay? And this is the last one. We are going to watch another video and we will take notes on the quadratic formula. The review day is next class. Your final test of this 9 weeks and of the semester is next Tuesday. Okay, so please either get out your notes or a sheet of paper that you will take very good notes on so that you will have good notes to use and to reference when you are taking your quiz today. I hope we will see only but hundreds on these quizzes. Here we go. Let's solve this equation by completing the square. Here are the steps that we need to remember. We want to turn this left side into an x plus or minus something squared. And then on the right side, we can have any number. This is our goal. Because when I have an equation like this, I can use the square root to square root both sides and just get x plus a number equals plus or minus the root of whatever that number was. Okay? To do that, we will remove whatever constants are bothering this x squareds and the x's. I'll say remove the numbers. By removing numbers, I mean like get rid of this 2. Subtract 2 from both sides. This gives you x squared plus 6x equals negative 2. I'm going to leave some space here. Okay? Because the second step to be able to turn this left side into an x plus something squared, I need this to be set up to be a perfect square. Now, I am thinking about using 3 because I know if I square x plus 3, I get x squared plus 3x plus 3x, so that's x squared plus 6x plus 9. So if I know I have x squared plus 6x, this 6x, that x squared and that 6x, come from x plus 3. Knowing that I need a 3, that means I need a 9. So I'm going to add a 9 to both sides. You don't have to do it like that, but it's nice if you do it like that. Okay. An easy way to find this number that I add to both sides, this 9 that creates this perfect square, you can add the b number divided by 2 squared. Here, b was 6. 6 divided by 2 is 3. 3 squared is 9. I added 9 to both sides. Okay? So, now I have x squared plus 6x plus 9 equals 987. We can rewrite this as x plus 3 squared. Remember, if you have x squared plus a term times x plus a number, you're looking for 2 numbers that add to get the middle term and multiply to get the last term. The 2 numbers are 3 and 3. So you could write this as x plus 3 times x plus 3. But we talked about how that's the same as x plus 3 squared. So we will probably help us, it'll help us to rewrite it as x plus 3 times x plus 3. Then after we write it as x plus 3 times x plus 3, we know to write it as x plus 3 squared. Okay? So we got x plus 3 squared equals 7. We've accomplished our goal of completing a square so that we can use the square root. When we square root both sides, we'll have x plus 3 left on the left side. On the right side, I'll have plus or minus root 7. We want to try to simplify this root 7. Are there any perfect squares that go into it? Remember, so I forgot the third step. Third step was to factor so that I have x plus a number squared equal a number, and then square root to solve. Perfect squares to simplify this root 7. 4, 9, 16, 25, none of those go into 7, so I can't. My last step would be to solve for x by adding -3, giving me x equals -3 plus or minus root 7. You can leave your answer like this, or write out both of them, -3 plus root 7 and -3 minus root 7. You cannot simplify roots and numbers. They are not like terms. So just leave it like that. Okay? So remove your number. Figure out the number to add to both sides so that it turns into a perfect square. Once you've figured out that number, add it to both sides. Factor, square root to solve. Okay? Now, I would like you guys to try that very same problem by yourselves without looking at your notes or looking at your notes sparingly. If the sub could pause the video while you do that, go ahead and pause the video now. And we should have finished and gotten the same answer again. It's important to be able to do this yourselves, these steps, without trying not to look at your notes, okay? Let's go to this next one. So let's write down this next problem. Now I have numbers on both sides, but it's the same process. Remove the stuff that is bothering x squareds and x's. So here, don't worry about this 10. Remove the 40 first. I get x squared plus 10x equals -50. Now, I know that when I square x plus 5, which is x plus 5 times x plus 5, I get x squared plus 5x plus 5x, which is 10x plus 25. So I know this needs to be an x plus 5. I know I need to add 25 to both sides. Now, you could do that, figuring out kind of how I'm doing it, or you could take b, divide by 2, and square it. 10 divided by 2 is 5. 5 squared is 25. That number is what you need to add to both sides. Okay, so now I have x squared plus 10x plus 25 equals -25. Okay? Now, if we factored the left side, we should see we would have a perfect square. The two numbers that add to get 10 and multiply to get 25 are 5 and 5. This can be written as x plus 5 squared. Notice, like the 5 is, we are not using 10. It's not x plus 10 squared. It's not x plus 25 squared. It's x plus 5 squared equals -25. We could square root both sides. I get x plus 5 equals plus or minus root -25. Okay, now let's be careful. It's the square root of a negative. So make sure we rewrite it as the square root of a number and the square root of -1. That way we know we have an imaginary situation where our solutions are imaginary. I get x plus 5 equals plus or minus 5i. I then can go ahead and subtract or add -5, giving me my solutions. X equals -5 plus or minus 5i. You cannot combine the 5 and the 5. You just leave it like this. Okay, so once again, what we did, got rid of the numbers. Numbers are gone. Figured out which number we need to add so I could turn this into an x plus a number squared. This is our goal, is to create this type of an equation. I figured out to add 25 by either taking b divided by 2 and squaring it, or just by thinking, oh, x plus 5 times x plus 5 is going to give me that 10x. 5 times 5 gives me that 25. So make sure you add it to both sides. We write it as our factored form, but not as x plus 5 times x plus 5. It's easier to write it as x plus 5 squared. And now I can square root both sides. I get x plus 5 equals plus or minus root -25. Don't forget the plus or minus. Since it's a root of a negative, we know it's an imaginary number. Split it up. Square root of 25 is a perfect square, so we just get 5. We can subtract the 5. We get our answers. Okay? All right, you guys, please do the same question. Try not to look at your work. Do it again. If the sub could pause the video for a couple minutes while they try it, I'd appreciate that. And now we're going to do another example. Third and last example. Let's say I just have my x squareds and my x's already isolated and my numbers already on that right side. That's great. We don't have to move anything. Okay? Make sure we've written this down. And notice, you don't have to move 8. Don't move the 8. You just got x squareds and x's. We're good. Now, either take b divided by 2 and square it. That's -6 squared, which is 36. Or, if you think about x minus 6 times x minus 6, which is x minus 6 squared, you would have x squared minus 6x minus 6x plus 36. That is another way to know that, oh, I should be adding 36 to both sides. And I need x minus 6 because that's how I get the x squared minus the 12x. So, I want to erase this. Add 36 to both sides. I get x squared minus 12x plus 36 equals 36 plus 8, 44. We are ready to factor this to turn it into this. The two numbers that add to get -12 and multiply to get positive 36 or -6 and -6. We know that that turns into x minus 6 squared. On the right side, just leave the 44. This is our goal. We need to get to something like this. We can now square root both sides. I'll get x minus 6 equals plus or minus the square root of 44. I think about large perfect squares that can go into 44. The biggest one is 4. I will rewrite this as root 4 root 11. I will add 6 to both sides to get my answer. X equals plus or minus 6 plus or minus 2 root 11. Okay? X squared minus 12x equals 8. You guys try yourselves. X squared minus 12x equals 8. Please solve that by yourself. Do it. Do not look at your answers. Try to do it by yourself. We can do it. Okay, if we could pause the video, that'd be great. And now I'm going to continue to do a couple more problems where we're going to be completing the square, but we're not going to be solving. Notice we do not have a 0 here. We have just a y. And we are asked to find the vertex. Well, we remember vertex form of a quadratic. We should write this down if we don't remember it. It's a times x minus h squared plus k. So the vertex is at hk. Notice the negative symbol, x minus h. So if it's x minus 3, the vertex would be at positive 3, comma, whatever this value is. Okay? I could turn this into something that looks like this by completing the square. The steps are the same. Get rid of the stuff that is bothering x squared and x's, like the 5. Now, what's different about this is the y needs to stay, and you'll just add 5 to y like this. Next, add something to both sides so that this turns into a perfect square. Let's think about it. If I had x plus 2 times x plus 2, that would give me x squared plus 2x plus 2x plus 4. That's x squared plus 4x plus 4. Oh, I need a 4 to be added to both sides. Or I could have taken this b, divided it by 2, and squared it. It's a shortcut to get there, but you got to understand why we are taking that. It's just kind of thinking about the distribution of x plus 2. All right, so I get y plus 9 equals x plus 2 times x plus 2. That's y plus 9 equals x plus 2 squared. Well, subtract the 9. We get y equals x plus 2 squared minus 9. That, my friends, is in vertex form. By looking at it, I know the vertex for my original equation, which can be simplified to look like this, is going to be at -2, -9. If you have your graphing calculator, you could graph this and see the vertex is at -2, -9. You should see that this and this, if you graph both of them separately, will end up on the same curve because it's the same equation. It just looks different. Okay? All right, you guys try yourselves. X squared plus 4x plus 5. Was it plus 5 or minus 5? I think it was minus 5. X squared plus 4x minus 5. Please find the vertex by completing the square. Okay, the sub could pause. Students, do it yourselves so that you know you can do it. And here comes the last one. One more, finding the vertex by completing the square. Remove the numbers bothering the x squareds and the x's. I always like to add an opposite rather than subtract. If you still haven't gotten your minds around being able to do that, I don't know. We'll figure it out once, eventually. Either take b, divide it by 2 and square it. So that's 4 squared, which is 16. Or know that you're going to have x minus 4 times x minus 4 to give you that negative 8x. Do that. Do either. Don't care. We know that if we add 16 to both sides, I'll have a perfect square here. I have x plus -4 or x minus 4 and x minus 4, which is x minus 4 squared. Over here on the left side, I'll have 16 minus 5, which is 11, positive 11. So I have x plus 11 equals x minus 4 squared. Subtract 11, y equals x minus 4 squared minus 11. So like the last step you might want to write down is to just move this number back over so we have vertex form, and we can see our vertex in this situation is at positive 4, negative 11. Okay, you guys try x squared minus 8x plus 5. Find the vertex by completing the square. This is the last problem. These notes you will use for your quiz. Go ahead, pause, and when the students are ready, have them keep their notes out and pass out the quiz, please. After everybody's done with the quiz, please turn it in. And the notes, the sub will pass out the notes on the quadratic formula, and we will watch our video on the quadratic formula. And you will take notes on the quadratic formula. We have the last quiz of the semester. Next class, we'll have the last test of the semester on Tuesday.